Hi, this is Leetcode question. Find the longest valid obstacle course at each position. In this example, for index 0, we have the longest subsequence, which is subsequence 1. For index 2, we have 1 and 2. Notice that the value at the index should be included, and though this is non-decreasing subsequence. At index 2 we have 1 2 3 1 2 3, so all of these values are before this index and include also the index itself, and this is non-decreasing. And at index 3 we have 1 2 3 1 2 2, and this is of length 3, this is length 1, this is length 2, length 3. So the question is the same as if we need to find the longest non-decreasing subsequence at each index. Now let's take this example. We start with the value 3. So 3, the length of this subsequence is 1, so the answer is 1. 1 is less than 3, so we start a new subsequence, and the length of this is 1. 5 is greater than both, so we can insert 5 here and here, and the length of these subsequences is 2, so the answer is 2. 3, now 3 is less than 5 and equal to 3, so it can be here or it can be here. So for this case it can be 3 3, for this case it can be 1 3, and the length of this subsequence is 2. And then we have 6 we can push it to this subsequence or this or this or this, and the length of these subsequences is 3. 4 we can have it here or here or in this position or in this position. So for this one we can have 3 4, for this one we can have 1 4, for this one we have 3 3 4, for this one we have 1 3 4, and the longest subsequence end at 4 is equal 3. Then we have 2 we can insert it here, so it come 1 2, or can insert it here, come 1 2, so at the end the subsequent length is 2, and so on. But this will consume a lot of space. We need a more efficient way to do it, and to do that we'll use binary search. So let's start at the value 3. The length of the subsequence is 1, so we add 1. So 1, what is the first element greater than 1 in the subsequence? It's 3. So it's better to start with the value 1 rather than start with the value 3. And the index of this value is 0 in this list. So we add to the answer the index plus 1, which represents the length of this subsequence. So the answer in this case is 1. This one. Then we have 5. What is the first element greater than 5? We use upper bound to do that. The answer is there is no element, it's at the end, so that means we can push the 5 to the end of the subsequence, and in this case we will push the list.size, which is the length of this array, is equal to. Then we have the value 3. What is the first element greater than 3 in this subsequence? It's 5, so it's better to start with 3 instead of 5, so we replace 5 with the 3, and the length of this subsequence equal to this is the index 0, this is 1, index 1 plus 1, and the answer is 2. Then we have 6. What is the value greater than 6? There is no value, so we can push 6 at the end, so the subsequence becomes 1 3 6, and this has length of 3. Then we have 4. Again, what is the first value greater than 4 in this list? The answer is 6, so we replace 6 with 4, and that means it's better to start from here at value 4 instead of 6. This gives us higher possibility to have longer subsequence, and again the length of this subsequence is 3. Then we have value 2. The first element greater than the value 2 is 3, so we replace 3 with 2, and this index is 1, so this is 0 1 2, meaning that the length of the subsequence is ending at this index equal to 1 plus 1, which is 2, which is the length of this sequence, so the answer is 2. Then we have 9. We can push it at the end, so right now we have 1 2 4. We can push 9 at the end, and the length of this is 9 is 4, so we push 4, which is the length of the list. Then we have 1. The first value greater than 1 is 2, so we take 2 and replace it with 1, and the length of this subarray until 1 is 2, so the answer is 2. And the last one is 10. We can push it at the end, and the length of the list is 5, so the answer is 5. The time complexity for this is big O of n, log n, because of the binary search. We have it here for upper bound.